Hello, hi everyone. Welcome to the Student the Brand. This is our Siva sir. Today we are going to discuss about electric current, grade 12. Electric current. So we are discussing electric current. 1 minute. Electric current or current electricity. Electric current or current electricity we can hear in this. I equal to Q by T. So first one. So charges are moving inside of the conductor. So positive charge, negative charge, positive charge, negative charge, positive charge, negative charge. So I equal to delta Q by delta T. So this is instantaneous current. Okay, instantaneous current. Instantaneous current. And this one we are considering average current. Average current. So 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. Okay. So SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. SI unit of current is ampere, SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. So 1 ampere equal to 1 coulomb per 1 second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. So 1 ampere simply we can say 1 coulomb of charge flowing through unit cross section area per second. Now, so conditions. So 3 conditions are there. We'll discuss those 3 conditions. Condition number 1. So flow of charge can be obtained by multiplying constant current and time interval. And second one is flow of charge. If time is a function of, if current is a function of time, by integrating, so Ti, so Tf, then I equal to delta T. And the third point is, so flow of charge can be obtained by area under the graph of, I into T, I into IT graph, the area of under IT graph. So current and time, current on y-axis, time on x-axis. Okay, so that's enough. This is about our current. And next one, based on the magnitude and direction, current can be divided into 2 parts. Based on magnitude and direction. Based on magnitude and direction. Based on magnitude and direction. based on magnitude and direction current can be divided into two parts. Current can be divided into one is direct current, another one is alternate current. First one is direct current, another one is alternate current. So direct current is nothing but direct current. So the magnitude and direction of current does not change. So it is constant. Magnitude and direction of current is same. Magnitude and direction will not change. It will be constant. Okay. So example, cell, battery and DC dynamo. Coming to alternate current, so both magnitude and direction changes. So example, AC dynamo. Okay. So direct current and alternate current. Cell, battery, DC dynamo. Alternate current is AC dynamo. Okay. Now, if the charge is moving in a circular path, okay, so Q is charge with the frequency F, then the current is, we can write current I equal to Q into F. So once again, based on the magnitude and direction, current can be divided into two parts. So direct current and alternate current. So direct current is example, or direct current, cell, battery and DC dynamo. For alternate current, AC dynamo. So if the charge is moving in a circular path, with frequency F, so current can be written Q into F. So Q into F. So I hope it is very clear. Now, so we'll go to the next one. Okay, now next one we'll discuss drift velocity and relaxation time. So here, so current is flowing and the electric field also there. So electrons are moving opposite to the electric field. If the electron is moving in the electric field, it experiences the force. Okay. So F equal to E into E or Q into E. Electric field is the electric field. So Q is a charge. Now we know F equal to MA. So MA into E or Q into E. So then we can take A equal to E by M or Q E by M. Okay. Now we will discuss about drift velocity. What is meant by drift velocity? So here, this is one electron. This is also one electron. So electron is moving in a closed path inside of the conductor. Okay. So when it is moving, so the electrons will move in a zigzag motion Electrons will move. Oh, user. Electric and current are same, different. Current electricity or electric current we can take. Okay. So charges are moving. Simply we can say charges are moving inside of the conductor. Charges are moving inside of the conductor. The movement of the charges inside of the conductor is called electric current. Okay. Charges. Here charges we can say. So water also we can say water. Water also you can see. So there also current will be there. So there also charges are moving. Okay. So it depends on the medium. So here charges are set. Positive charge, negative charge. Charges are moving inside of the conductor. That's why we are saying electric current. Thank you so much. User present. User W40. Thank you. Okay. Now, so we'll discuss. Here electrons are moving inside of the conductor. Electrons are moving inside of the conductor. So in a zigzag motion it is moving. In zigzag motion it is moving. Okay. Then what happens? This electron will hit the another electron. This electron will hit the another electron. So when keep on colliding takes place. When keep on. See, so this electron will have particular velocity. So this electron will have particular velocity. So when after collision, the electrons will exchange the velocity. Electrons will exchange the velocity. Okay. One electron will hit the another electron. One electron will hit the another electron. Then velocity of the electrons will exchanges. Then automatically, so velocity changes. After each collision, velocity changes. Yes or no? After each collisions, velocity changes. Then the average electron, the average velocity of an electron, the average velocity of an electron is called drift velocity. Average velocity of an electron is called drift velocity. Thank you, user. Double 5T. Okay, so electrons are moving with the velocity, so it will collide each other. Okay, so after each collision, the velocity will changes. So one electron to another electron velocity will be different. Velocity will be different or not? Velocity will be different. So that we average the average velocity of an electron is called drift velocity. Okay, so after collision, this electron will have particular velocity, this electron will have particular velocity, this electron will have particular velocity. So after each and collision, so the velocity will changes. That is called drift velocity. So the average velocity of an electron is called drift velocity. I hope it is very clear. Next, that is VD. Now relaxation time. Here I already. The average, so okay, fine. So come to the point. The average, now actually, so year to year collisions will takes place, right? So one collision to another collision, time will be there. So here, so this electron will hit the another electron, this electron will hit another electron, this electron will hit another electron. So after collision, after each and every time collisions will takes place, so this will hit this electron, this will hit this electron, this will. So each and every time collisions will takes place. Collisions will takes place. Certain time will be there. Yes or no? Certain time will be there. So the average time between the two successive collisions, the average time between the two successive collisions is known as relaxation time. Relaxation time. Relaxation time is nothing but the average time between two successive collisions. Actually, this electron will hit another electron, this electron will hit another electron. So these collisions will take place each and every time. Collisions will take place or not? Yes. So the average time between the two successive collisions is known as relaxation time. Okay, so I hope it is very clear. So that is about drift velocity and relaxation time. Clear? Now we will discuss about current and drift velocity. Current and drift velocity. Current and drift velocity. Now we will discuss current and drift velocity. So here I am considering this one. This is a conductor. This is the area of the cross section A, and this also area of the cross section A. Okay. Now you can observe here. This is the length of the conductor. Displacement we can take, and we can observe one. Are you a student? User W. I will explain. Don't worry, I will explain. But thank you. So here area of the cross section, length, and as I said, current is flowing here. Current is flowing, and this one is electric field. Current and electric field. Okay, so this is a current and electric field. Now you can observe here. We know velocity equal to displacement by time taken. Velocity equal to displacement by time taken. So Vd equal to L by delta T. So listen carefully. So L equal to Vd into delta T. Okay. So this length is Vd into delta T. Okay. So I hope it is very clear now. Check once. Understood? Now, volume equal to length into area. Volume equal to length into area. Volume equal to length into area. Length is nothing but Vd delta T into A. So length is this one, and here you already wrote here. Okay, Vd delta T into A. Now, so in this particular volume, how many electrons are present? So this is the drift velocity. So electrons will move in this direction. That's why. So in the last class, one student asked me, "Sir, you mentioned only one direction. Electrons will not move only one direction. So they'll move in zigzag motion." Yes, I can understand. It will move in zigzag motion. But this is the drift velocity. So electrons will move in this direction. That is the reason I mentioned here. Okay. So in this direction I mentioned. I hope it is very clear to you all. Right? Now, so in this particular volume, how many electrons are present? In the particular volume, how many electrons are present? Now I will discuss. Okay, number of electrons. Number of electrons. Number of electrons in this volume. Okay, so if you are taking this volume, how many electrons are present? How many electrons are present? So now you can see here, that is N into Vd into delta T into A. Number of electrons present in the particular volume. Number of electrons present in the particular volume. Now, so we can take, we know delta Q equal to the formula. Delta Q equal to, what is the formula? Delta Q equal to delta Q equal to, so N into E, or nothing but number of electrons we can take. Number of electrons, that is N into Vd into delta T into A. Okay, into E. Now delta Q equal to NVD delta T into A and V. So we know current. What is current? Current I equal to delta Q by delta T. N into Vd into delta T into A E by delta T. So can we cancel delta T? So I'm cancelling delta T into delta T. So then you will get N Vd into AE. So I equal to NVDAE. Okay, or NEVD also we can write. NEAVD. I hope it is very clear. Now we can take current density. Current density equal to, so what is the current density formula? Current density I equal to J equal to I by A. J equal to current density, J equal to I by A. So J, I equal to how much? N E A V D by A. So A get cancelled. So J equal to N E V D. So this is the form. J is nothing but current density. J is nothing but current density. So J is the current density. Current density. Okay, so I hope it is very clear. So this is about current and drift velocity. Current and drift velocity. And the last one is current density. Once again, listen carefully. So current is moving in the conductor. Current is moving the conductor. Electric field will be there. So electrons will move opposite to the electric field. So velocity equal to length by or displacement by time. So Vd equal to L by dt. L equal to Vd into delta t. V equal to L into A. So V equal to Vd into delta t into A. Volume if you are taking. Volume you are considering. Now number of electrons present in this volume. a number of electrons present in this volume, a number of electrons in the particular volume, in this volume. So n equal to n Vd delta T into A. So delta equal to n into A. So n we know that. So n Vd delta T into A. So delta Q equal to n Vd delta T into A. So I equal to current equal to delta Q by delta T. So delta T get cancelled, n Vd A into D. So now you will get this value. Current density J equal to I by A. Current density J equal to I by A. Then you will get the answer. So this is about current and drift velocity. Now we will discuss about one more. Okay, so next one. Next we will discuss about resistance and resistivity. Resistance and resistivity. So resistance. Here so resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. R is directly proportional to L by A. R equal to rho into L by A. R equal to rho into L by A. Okay. So now you can observe here rho equal to RA by L. Rho equal to RA by A. R equal to rho into L by A. Rho equal to R by A. Okay. So now R is resistance. R is resistance. Rho is resistivity. Rho is resistivity. Resistivity. R is resistance. Rho is resistivity. Okay. Now you can observe here. Now you can observe. So resistance and resistivity. Resistance and resistivity. Resistivity. Point number one, you can observe point number one. So R equal to rho into L by A. R equal to rho into L by A. Rho equal to R by A. R by L. RA by L. RA by L. And second one, SI unit of resistance is ohm. SI unit of resist is ohm meter. And third one is resistance depends on temperature and resistivity depends on temperature. And fourth one, resistance depends on material of the conductor. Material of the conductor, and resistivity also depends on material of the conductor. Okay, resistance and resistivity. Resistance and resistivity. Okay, I hope it is very clear. I hope it is very clear. So resistance and resistivity. And resistance also depends on length of the conductor, and resistance also depends on area of the cross section. Resistance depends on length of the conductor, resistance also depends on area of the cross section. So this is about resistance and resistivity. Resistance and resistivity. Okay. Now, temperature dependence of resistance. Temperature dependence of resistance. Temperature dependence of resistance. Okay. Now we'll discuss. Normally, when temperature increases, so if you increase the temperature, number of free electrons increases. So in the conductor, number of free electrons increases, so that movement of the electrons also increases. So electrons will move with a greater amplitude. Electrons will move with a greater amplitude, with a more frequency. So more velocity, the electrons will move in the conductor. Okay. So what happens when electrons are moving with a greater amplitude, higher amplitude? That time conductivity increases, resistance and resistivity decreases. So two things will happen at a time. So one by one I am discussing. Point number one, when temperature increases, so free electrons increases, movement of the free electrons increases. So electrons will move with a greater amplitude. Okay, so more frequent it will move. Then the times collisions will take place. So one-to-one collisions will take place. More collisions will take place. More frequently collisions will take place. Yeah, this is for JEE and NEET, so anyone can watch, no problem. Okay. So now you can observe. You can see. So T R O. So electrons will collide each other, bombard each other. Collisions will take place frequently. Then what happens? What happens that time? Temperature increases, resistance and resistivity also increases. So collisions will take place, then resistance increases. Okay, collisions, electrons will not move forward. So in that place only, keep on bombardment, keep on collisions will take place. By that reason, resistance and resistivity increases. So R is a resistance, R is the resistance, rho is the resistivity, rho is the resistivity, and so R is directly proportional to L, R is inversely proportional to area of the cross section, R is directly proportional to L by A, R equal to rho into L by A. So if temperature increases, length and area of the cross section also increases. That is so very less comparable. So minimal changes will be there. That's why then R is directly proportional to rho. So R equal to a temperature T, R naught is a temperature T naught, rho is a temperature T, rho naught is a temperature T naught. Okay. So T naught. Now, so we can write like this. That is, so R equal to R naught 1 plus alpha into T minus T naught. So T minus T naught. Now you can observe here T naught. Now R equal to R naught plus R naught into alpha T minus T naught. Then R minus R naught equal to R naught into alpha into delta T. So we can take delta T. So I need alpha. Alpha is the temperature coefficient of resistance. Temperature coefficient of resistance. R naught into delta T. So here if it is comes, temperature coefficient of resistivity, rho we can take as it is, rho we can write because directly proportional. So rho into rho naught by rho naught into delta T. So that's enough. That is about temperature dependence of resistance. Is it clear? So check once. I'll be back in 1 minute. Hi everyone, welcome back. So now Ohm's law will discuss. Ohm's law. So Ohm's law. Ohm's law is nothing but the potential difference across the ends of the given metallic conductor. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at constant temperature. And also physical conditions are same. Once again, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I. So V equal to IR at constant temperature. So that is very, very important. V equal to IR. Okay. And so if you are taking V and I graph, V on Y axis, I on X axis, the graph is linear. The graph is linear. Okay. The graph is linear. The graph is linear. The graph is linear, right? So that is for ohmic conductors. That is for ohmic conductor. The substances which obey Ohm's law, the substances which obey Ohm's law, those are called ohmic conductors. The substances which does not obey Ohm's law, those are called non-ohmic conductors. Non-ohmic conductors. The substances which obey Ohm's law, those are called ohmic conductors. The substances which does not obey Ohm's law, those are called non-ohmic conductors. Okay, so here I'm taking. So here the graph is like this. V on y-axis, I on x-axis. The graph is like this. Okay, so curve. Now we know that V equal to IR. So it is also applicable for non-ohmic conductors. But the reason is, so if you are taking a graph like this, so V on y-axis, I on x-axis for non-ohmic conductors. Like I1, I2, V1, V2. So V1 by I1 equal to R1. V2 by I2 equal to R2. Okay. So I hope it is very clear. Just check once. So ohmic conductors and non-ohmic conductors. So in this case, R2 is not equal to R1 because slope is different. R equal to V by A, right? V by A. So R2 is not equal to R1. Okay, so I hope it is very clear. Now electromotive force, EMF. Now we'll discuss about electromotive force. Electromotive force. Electromotive force. Now you can check here. Cell. Normally if you connect cell, current automatically passes from positive terminal to negative terminal. Okay, so positive charges will move from positive terminal to negative terminal. That is nothing but high potential to low potential. Charges will move from high potential to low potential after connecting. Electrons will move from, so positive charges will move from high potential to low potential. Electrons will move from low potential to high potential. We know this one. But positive charge from negative terminal to positive terminal. Okay, so charges should move from negative terminal to positive terminal inside of this cell. So who is responsible? Who is responsible to move that charge from negative terminal to positive terminal inside of this cell? So the force which is responsible, okay, na? The influence that can move the positive charge from negative terminal to positive terminal is called EMF, electromotive force. EMF is nothing but work done on positive charge to move from negative terminal to positive terminal in the cell. That is called EMF. Okay, so that is about electromotive force. Next one, resistors are connected in series combination. Resistors are connected in parallel combination. After that, Kirchhoff's law. Kirchhoff's law. Okay. Now, resistors are connected in series combination. Resistors are connected in parallel combination. Resistors are connected in series combination. Resistors are connected in parallel combination. I am taking 1, 2, 3. So 3 resistors, current. So here solar battery I am taking here. Solar battery like this. Positive terminal, negative terminal, current is flowing. So this is R1, R2 and R3. So V1, V2 and V3. So 3 voltmeters connected across R1, across R2 and R3. Yes or no? No. So in the circuit, entire circuit current is same. Is equal to I1 equal to I2 equal to I3 equal to I. Okay. But potential difference is different. In the circuit, potential difference is different. So Vs equal to V1 plus V2 plus V3. So from Ohm's law, V equal to IR. From Ohm's law, V equal to IR. Yes or no? Now you can substitute. IR is equal to IR1 plus IR2 plus IR3. Now I am taking I common. Rs equal to I am taking R1 plus R2 plus R3. So I get cancelled. Rs equal to R1 plus R2 plus R3. So if resistors are connected in series combination, Rs equal to R1 plus R2 plus R3. If n number of resistors are connected in series combination, Rs equal to Nr. Rs equal to Nr. Okay. So now resistors are connected in parallel combination. Resistors are connected in parallel combination. Now you can see here. So across this is R1, R2 and R3. So voltmeter I am connecting. Okay. So now you can observe here. So positive term, negative term current is start flowing. R1, R2, R3 across R1, R2, R3. So potential difference is connected. V is connected now. From Ohm's law, V equal to IR. From Ohm's law, V equal to IR. I equal to V by R. I equal to V by R. Right? So V equal to IR, I equal to V by R. V by R. I hope it is very clear. Right? Now you can observe IP equal to I1 plus I2 plus I3. So V by RP equal to V by R1 plus V by R2 plus V by R3. So I am taking V common, V get cancelled. So we can take V common. 1 by RP equal to V I am taking common 1 by R1 plus 1 by R2 plus 1 by R3. So V will get cancelled. Now 1 by RP equal to 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, so I hope it is very clear to you all. So across this one I1, I2 and I3 current is different. Okay, so check. If n number of resistors are connected in parallel combination, if n number of resistors are connected in parallel combination, so 1 by Rp equal to n by R, Rp equal to R by n. So n number of resistors are connected in parallel combination. 1 by Rp equal to n by R, Rp equal to R by n. So this is about resistors are connected in series combination. Resistors are connected in parallel combination. So that's enough. Now we will discuss about Kirchhoff's law. Okay. Now we'll discuss Kirchhoff's law. First law and the second law. There are two laws are there. One is junction law, another one is loop law. Junction law and loop law. Junction and loop. So what is junction? Junction is nothing but a point in the circuit where all two or three conductors meet at one point in a circuit, that is called junction. Loop is any closed conducting path. Any closed conducting path. So junction law, first one. So junction law is nothing but the algebraic sum of all the currents reaching at a junction. So algebraic sum of all the currents, reaching in an electric circuit. Okay, at a point. So if you are taking here, this is I'm considering like this. So this is I1 and this is I2 and this is I3 and I4. Okay, so this current if you are taking I1 plus I2 and the remaining currents will be taken like this, will be 0. And coming to the second, so here in second law there are 4 points. So if you are passing through the cell, source of energy, so this is positive or negative. So I am taking this the path, so current is passing like this. So you are moving from negative terminal to positive terminal. Negative to positive, then EMF is positive. And the second one is where you are moving positive terminal to negative terminal. So EMF is positive terminal to negative terminal through the source, through the cell. Okay, so that is EMF is negative, electromotive. The next one, third one. So this is the resistor. If you are passing through the resistor, so like this, so path, and this is the current and resistor. The IR term, potential drop, so decreasing potential, then we can take minus IR, or if you are taking current here, then it is I and IR. And fourth one, this is the resistor. If the current is moving, if you are taking the path like this, so this is the resistance and I, this is the current, then IR is positive because you are moving opposite to the current direction, increasing potential. Potential is increasing here, potential is decreasing here, so you are moving from positive to negative. So EMF is negative. When you are moving from negative to positive through the source, EMF is positive. Okay, so I hope it is very clear. This is about Kirchhoff's law. Then only grouping of cells. So it will take time. Grouping of cells I will explain in the next class. Nearly it will take 40 minutes like this. So thank you so much for joining and attending, listening my class. If you like the video, if you like the explanation, please do like, share and subscribe to Student the Brand. So if you like the content, ask your friends to join to the class. So this is Resistor from Student the Brand. Thank you so much. And also, so every day at 9 p.m. we'll be having demo classes. So for various subjects, okay, so like chemistry, maths, biology, social, like that, Hindi. So like a different subject demo classes are going on. Attend the classes, check the classes. If you like the classes, if you like the explanation, you can take classes from them. So automatically you'll get the idea. So most experienced faculty members are available to teach you. So attend the class. Once attend the class, attend the demo classes. You can check the community post. Once check the community post, definitely you'll get it. Okay. So thank you so much. This is Siva sir from Student the Brand. Thank you so much. We'll see you in the next class.